In this always-on world we live in, every single business has one goal that's completely non-negotiable: stay online. It doesn't matter if you're running a huge database, a web app, or your entire company on virtual machines, uptime isn't just some metric on a dashboard. It is the absolute lifeblood of your entire operation. So let's dive into the tech that's specifically designed to make sure the lights never ever go out: failover clustering.
All right, let's kick things off with a question. Just think about this for a second. With all the things that can go wrong, hardware dies, a network cable gets unplugged, the power goes out. What do you think is the single most expensive minute your business could possibly have?
Yep, it's the minute you're offline. That 1 minute can mean lost revenue, sure, but it's also about frustrated customers, a reputation taking a hit. It's the problem that genuinely keeps IT pros up at night, and it's exactly what we're here to talk about solving.
So how do you actually guard against that one catastrophic minute? Well, you need a safety net. And in the world of Windows Server, that digital safety net has a very specific name: failover clustering.
At its core, the idea is actually pretty simple. It's what we call a high availability feature. And what it does is it takes a bunch of separate independent servers, we call them nodes, and gets them to work together like they're a single unified team. The whole point? If one server goes down, another one is right there, ready to take over instantly.
To really get a picture of this, think about it like this. Imagine your most important servers are a team of high-flying trapeze artists. Each one is up there performing some incredibly vital and complex task way up high.
And there it is, the failover cluster. That's the safety net stretched out right below them. If one of those acrobats, one of your servers, slips up and falls, the net is right there to catch the workload seamlessly. For the audience, for your users, the show just goes on without a single missed beat.
Okay, so let's peek behind the curtain and see how this safety net is actually put together. It really comes down to 3 key parts. First, you've got the nodes. Those are our acrobats, the individual servers doing the work. Then you have cluster shared volumes. Think of this as the circus ring itself. It's a common storage space that all the servers can see and use at the same time. And finally, the quorum and witness. This is the referee. It's the official decision maker that makes sure everything runs smoothly, and we're about to see just how critical that is.
So, the quorum's #1 job is to prevent an absolute nightmare scenario that we call split brain. On the left, you see a happy, healthy cluster. Everyone's talking, everyone agrees on who's in charge. But look at the right. If a network connection breaks, you could have 2 halves of the cluster that can't see each other. Both halves might think they're in charge and start writing data. You got 2 conflicting brains, and that leads to chaos and data corruption. The quorum is that independent tiebreaker we talked about. It steps in and prevents this disaster, making sure there's only ever one brain in control.
Now, this technology isn't just sitting still, right? It's always evolving. So let's talk about the latest version, Windows Server 2025, and see how this digital safety net is getting even stronger, smarter, and a whole lot faster.
First off, let's just talk about sheer scale. In the latest version, we're talking about support for up to 64 nodes in a single cluster. I mean, that's not just a safety net anymore. That's a massive stadium-sized platform built for resilience, capable of handling absolutely enormous workloads.
In the 2025 version brings some really big upgrades. Storage is tougher now, especially for smaller clusters. For disaster recovery, you can now stretch a cluster across 2 different physical sites. They've even added a way to build a cluster without needing Active Directory at all, which is huge for simplifying things in smaller offices. And of course, under the hood, a ton of optimizations make everything just plain faster. But there is one new feature that really stands out.
And it's a total game changer. It's called GPU P-Live Migration. For the first time, you can move virtual machines that are using dedicated graphics cards from one server to another with 0 downtime. I mean, think about that. For anyone running critical AI models or heavy machine learning jobs, this is massive. It means those incredibly long training and processing jobs never have to stop.
Okay, so the tech is super impressive, but where do you actually see it in action? Let's take a look at how failover clustering is being used out there in the real world, keeping critical services online day in and day out.
So let's just walk through it. Here's a perfect example using Hyper-V. So step 1, boom, a physical server that's running a bunch of your virtual machines just dies. Step 2, the cluster sees it happen instantly. Step 3, it automatically starts moving those virtual machines live over to another healthy server in the cluster. And the result? Step 4, for your users, nothing. They experience virtually 0 downtime. It's like it never even happened. It's just seamless.
And it's not just for virtual machines. This is the exact same technology that keeps your SQL databases up and running, always ready for transactions. It's what makes sure your company's shared files are always accessible, even if a file server goes down. Really, any application that you absolutely positively cannot afford to have go offline is a perfect candidate for a failover cluster.
So, as we start to wrap this up, what's the big idea here? What's the philosophy behind all this tech? Well, it really all boils down to one powerful concept: proactive resilience. See, failover clustering isn't just about recovering from a problem after it happens. It's about designing your entire system with the expectation that failures will happen. It's, as the source material puts it so well, a proactive strategy for infrastructure resilience. You're building a system that doesn't just wait for problems, it anticipates them and handles them automatically.
And that really leaves us with one last crucial question to think about. It's the question this technology forces all of us to ask about our own systems. Is your infrastructure just built to run until it breaks, or is it truly designed from the ground up to fail over?